Right, we need to consider all the things that go around experiments. The first one is independent versus dependent variables. I've highlighted over here, I changed the independent variable, the letter I. So, I chose to compare white chocolate and dark chocolate. I changed whether I was melting white chocolate or whether I was melting dark chocolate. So, it is the type of chocolate that is the independent variable. I chose to compare if an orange or a nut falls fastest. What did I change? I changed the orange, I changed the nut. So the falling object was my independent variable. The dependent variable changes as a result of the changed independent variable. So in other words, the type of chocolate meant that there would be a different time. So it's how long did it take. So time is my dependent variable, and how long did it take an object to fall. Time is my dependent variable for both these experiments. We need to know the difference between two words, precision and accuracy of our results. When we repeat an experiment 3 times, that generally helps us to get precise results and then eventually to get accurate results. If we've got a lot of precision, we usually get some accuracy out of it. Precision means that you can get the same result doing the same experiment a number of times. How close together are these results? Precision is a measure of the degree of variability. In other words, how different are the results? Accuracy means that you get the correct result for the experiment. So if there's a documented value, for example, gravitational acceleration is documented to be 9,8 meters per second squared. That's how fast an object should fall in terms of how its rate of falling. If I get an answer like that, then I have got an accurate answer. So let's look at an example. You could do an experiment to determine gravitational acceleration. You could repeat the experiment 3 times. Let's say you got 16 meters per second squared 3 times in a row. Then your results would be precise because they would be unvariable. They would be close together. But they wouldn't be accurate because 9,8 is the right answer. On the other hand, you maybe get 3, 10, and 16. If you average those, you land up at more or less 9,8. Your answers are not precise because, as you can see, they're all over the place, but they are considered to be accurate. Here's another way of looking at that. So, if I were to be throwing darts at a bullseye on a dartboard, so there's my bullseye, and I'm throwing darts. I throw 5 darts, and they land up in these positions over here. These are neither accurate nor precise. None of them have hit the bullseye, not accurate. They're not precise because they're not close together. However, if I throw 5 darts and the bullseye is over here, and that's where I should be hitting, I find that my answers are all clustered together in one place. Those are precise. So that is a precise pattern, but it is not where I want it. I needed it in the bullseye, so it is not accurate. If I have got these, so I've got 1 dart in the middle and 4 around like that. If I average that out, they would all look like they were supposed to be about there. So that is accurate because it averages out correctly, but they're not in the middle. So that is not precise. Imprecise, 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 and imprecise. What about this? Here we have got 5 darts in the bullseye. That is both accurate and precise. So that is a way of visualizing accuracy and precision. The other thing you need to consider in any experiment is where did things go wrong? How did we have sources of error? You often ask this in experiment, what was not possibly right? Friction is your ultimate source of error. Air friction or friction of surfaces, because it means that things are working against your forces. So experiments are often filled with errors. As good scientists, we need to be able to know what the potential errors are. There's the problem of human error. Humans are not very good at pressing buttons, especially if the time period is very, very short. Friction, air friction, or friction of surfaces gets in the way of forces working perfectly. And expired chemicals, often the chemicals have reacted with the oxygen in the air and no longer work as expected. Those are some sources of error. you would need to consider the experiment specifically to decide on other sources of error. Your sources of error and the precision and the accuracy should be discussed under interpretation of results.